The view of the starry night sky is simply overwhelming. Billions of twinkling stars stretch across the vast canvas above us, an awe-inspiring sight that humbles and fascinates us. Yet, despite its grandeur, this celestial spectacle only reveals a minuscule part of the greater cosmic tapestry. From our position on Earth, we are limited in what we can perceive. In truth, we can only observe an infinitesimal fraction of the universe. This means we are fundamentally incapable of describing the full shape and extent of the cosmos. But this realization inevitably sparks a deeper question: what wondrous phenomena lie beyond our optical range? Is it even possible to discover what's out there, beyond the boundaries of what we can see? Surprisingly, the answer appears to be yes. Some data doesn't just suggest, but practically screams, that something colossal is lurking just outside our visible universe, an enormous structure, stretching its gravitational arms toward the known universe. To understand why our earthly view falls short in capturing the complete nature of the cosmos, we must first accept a profound truth: the universe has put natural blinders on us. This restricted perspective defines what we call the observable universe. Assuming the cosmos is both isotropic and homogeneous, that is, it appears the same from all locations and directions, we end up with a spherical space centered around Earth that defines our cosmic field of vision. Interestingly, every point in space has its own observable universe. These spheres can overlap but are inherently unique depending on the observer's location. The next logical question is, how far can we actually see into the universe? One might think that since the universe is about 13.8 billion years old, the furthest we can see would be 13.8 billion light-years away. However, that assumption would be incorrect. Due to the continuous expansion of space itself, the true distance to our observational horizon is roughly 46.3 billion light-years. When the light from those distant objects first began its journey, the universe was much smaller. Those sources were only about 40 million light-years away. But thanks to cosmic expansion, the space between us and those objects has been dramatically stretched. This concept leads to a stunning realization: when we observe these remote galaxies, we're not just looking far away in space, we're peering back in time. Because light takes time to travel, the further away an object is, the older the light we see. And because many of these galaxies have long since crossed the event horizon, we cannot know what is happening there now. In essence, observing distant galaxies is a form of cosmic time travel, giving us insight into ancient epochs of the universe. Given all this, one might assume that attempting to answer the question of what lies beyond the observable universe is a fool's errand. And yet, scientists haven't given up. Despite the enormous challenges and natural limits, some researchers believe they've detected the influence of something beyond our cosmic horizon. Their discovery? A mysterious phenomenon known as the dark flow. To appreciate the significance of this, we must start with one of cosmology's foundational principles. According to standard models, galaxy clusters should move randomly in relation to the cosmic microwave background, CMB, the leftover radiation from the Big Bang that still permeates the universe. However, data collected by NASA's Wilkinson Microwave Anisotropy Probe, WMAP, which operated from 2001 to 2010, told a different story. When Alexander Kashlinsky and his team analyzed this data in 2008, they uncovered a strange, coherent flow of galaxy clusters moving in the same direction. Even more puzzling, the velocity of this flow appeared to increase with distance. This behavior contradicted everything scientists had expected. Such a coherent movement could only be explained by the presence of a powerful gravitational force pulling on these galaxies, one that must lie beyond the observable universe. This inexplicable phenomenon was soon dubbed the dark flow. The concept gained further traction when a follow-up analysis in 2010 suggested that not just 700, but over 1,400 galaxy clusters were participating in this mass migration. Although the exact direction varied slightly across different regions, the general alignment remained consistent. What could be causing this immense pull? One theory posits that a massive structure beyond our visible cosmos is exerting a gravitational influence strong enough to affect entire clusters of galaxies. If true, This would mean that our universe is being shaped by something we cannot directly see. For Kashlinsky and his team, this discovery hinted at a deep and mysterious truth, that somewhere out there, beyond the limits of our perception, the universe is drastically different from what we observe locally. As he put it, we don't have enough information to see what it is or narrow it down. The only thing we can say with certainty is that somewhere far away, the world is very different from what we see locally. Naturally, not everyone agrees. The dark flow theory has faced considerable skepticism. Critics argue that the data used to support the theory might be flawed. Some researchers point to methodological issues, such as not properly accounting for the directional dependence, also known as anisotropy, of the cosmic microwave background. A separate analysis involving more than 550 supernovae found no sign of a uniform flow. Additionally, data from the ESA's Planck satellite, which offered higher resolution readings of the CMB, found no evidence of dark flow either. So, is dark flow real, or was it a statistical mirage? Opinions are divided. While many in the scientific community have moved on, Kashlinsky remains adamant. He emphasizes that his findings are based on over 1,000 galaxy clusters spread across vast distances, data that, in his view, cannot be explained away as coincidence. Assuming Kashlinsky is right, what implications would that have for our understanding of the universe? Simply put, it would mean there is something beyond the observable edge. But what exactly lies beyond that cosmic curtain? Here, speculation abounds. One conservative theory holds that the structure of the invisible universe mirrors that of the visible one. In an infinite universe, every possible scenario must exist, including identical copies of the solar system and even of ourselves. In one version, you had cereal for breakfast. In another, you chose toast. In yet another, you may have skipped breakfast entirely, or done something wildly different. Some researchers believe that somewhere out there exists an observable universe that is completely identical to ours in every way. It's a mind-bending idea, but one that aligns with the true meaning of infinity. With infinite space comes infinite possibilities. However, not all models assume uniformity. Another theory proposes that our universe is merely one bubble in a vast foam of subuniverses. This concept is rooted in the idea of eternal inflation, a process where space continues to expand forever but occasionally forms pockets where inflation stops, creating isolated universe bubbles. Each bubble could have its own laws of physics, constants, and dimensions. In some, gravity may be stronger or weaker, in others, time may flow differently. This idea dovetails with string theory's multiverse hypothesis, which suggests that every logically consistent universe actually exists somewhere. According to this framework, the reason life exists here is because, out of all the possibilities, at least one universe had the perfect conditions for it to emerge, and we happen to live in that one. The dark flow might then be a hint, a small crack in the veil, suggesting that our universe is not alone. It might be part of something far grander, an interconnected web of realities, each more fantastic and strange than the last. Whether it's an alternate version of our own world or a dimension governed by unfamiliar laws of nature, the possibilities are staggering. In the end, the mystery of what lies beyond the observable universe remains one of the most profound and tantalizing questions in science. It challenges our assumptions, stretches our imagination, and invites us to consider that reality may be far more complex than we ever thought possible. Whether the dark flow is real or not, the quest to uncover what's out there is far from over. As long as we continue to gaze at the stars, we'll keep wondering, and exploring, the great beyond. Stay curious, stay cosmic, only on Space Lab.